Welcome to the math record. Today we'll be learning about force and velocity vectors. This video will cover part 2 of chapter 9 of our Precalculus class. Okay, let's get started. In our previous video, we said the general form for a vector would be in v is equal to like ab, or it could be represented as ai plus bj. Now we're going to write this into polar form. So basically, what you're going to be doing is now, instead of v is those forms, we're going to have v is equal to the magnitude of v times, let's just put parentheses, which is times cosine of theta, an angle, I, which is the change in x, plus sine of theta times j. J is outside the theta. So sine of theta inside with the parentheses and times j. But I usually just write it this way. So, okay. So this will be the general form used to calculate like force and velocity vectors. So the the magnitude of v will calculate the force and the speed basically. And speed. I'll be explaining this further in the examples basically. Force and velocity vectors are basically the same. They're just kind of named differently. So then like the force velocity deals with like forces basically, and velocity vectors deals with like speed and direction. So let's work with like force vectors first. So let me give you an example. Delete this first. We need more room. So imagine there's like a ceiling, right? And there's two wires, and then there's a box. The box weighs 100 pounds, and we have a one wire that makes like a 30 degrees and another wire that makes like a 45 degrees. So you want to find out like what's the force of the wire for this one and the other force of the other wire. So you want to find these two forces for the wires. So there is a concept called static equilibrium, which applies to like force vectors. Equilibrium, right? This states that all the vectors acting on an object, like basically this box, if this like box is not moving, that means all the vectors adding to it will be equal to 0. So it's equal to 0, all the vectors adding up to it. So how does this apply to our situation? Well, first we need to find all the vectors if we want to add them to 0. So we have a vector on this wire, we have a vector on this wire, and we have a vector on this box, because this box is weighing something, right? So just think about the box first. So the box will be pulling it down, so that will make like a force. But then there's a wire here, which is kind of stopping it, so this will be another force. And then there's a wire here, which is also stopping it, which will be also kind of like pulling on this force. So there's three forces. There's vector 1, there's vector 2, and vector 3. So vector 1 I'll put as the first wire, vector 2 is the second wire, and vector 3 is the box. So basically, we need to find the the vectors, like the forces. So first we want to understand like what angles these are working at. It might be like just 30 and 45, but you got to think about this into the entire angle. So imagine this is like another line, and you make a plane right here, right? Basically, this is 30 degrees, right? So if you're making that line, this also has to be 30 degrees. Makes sense? Because this box is parallel to like the ceiling. Because it has to be. Because it has that rest. It's at rest. And then you have an angle right here, and this is 45, right? So you make that coordinate plane, right? If this is 30 degrees, then this is 150 degrees. And this is just 45. So you have to look. So the first vector is 150 degrees, and the second vector is 45 degrees. So we have vector 1. We want to find the force, which is just the magnitude of v, but we don't know it. So times cosine, we set it's 150 degrees because this over here is 30. So that's 150 I plus sine of 150j. And we have vector 2, which is force 2 times that's 45 degrees right here. This is parallel. So we have cosine of 45 I plus sine of 45j. And we have the third vector. This vector is just basically kind of gravity. So it's just pulling the box down. Since the box weighs 100 pounds, then it's just going 100 pounds down. So that would just be vector 3 is equal to negative 100j, right? Because you're just moving it down. So that's the basic general like equations for these. Sorry, I'm move these. You can't see the picture anymore. I just need room. Sorry about that. So now let's say now we just need to simplify this. So we have vector 1 cosine of 150 degrees. It's basically the same thing as sorry, let me put the force 1 vector down. Same thing as square root 3 negative square root 3 over 2, right? Because this is in the second quadrant. And then sine of 150 degrees is 1/2. And then vector 2, which is force 2 right here, magnitude, times cosine of 45, which is square root 2 over 2. And the other sine of square root 2 over 2, j. So we have 2 square root 2's over 2's. And the vector 3 is basically the same thing, which is 100j. Okay, so now we have it in the, instead of polar form, we have rectangular. It's easy to deal with. And now we just had to make, so for static equilibrium, it states that vector 1 plus vector 2 plus vector 3 adds up to 0, right? So since there's i's and j's, the i's had to add up to 0 and the j's had to add up to 0. So we have force 1 times, wait, sorry. I'm not going to be writing the I, so we have negative square root 3 over 2, right? Times force 1 plus, we have the other I is right here, which is square root 2 over 2, times force 2, because you have to distribute out the forces to the other side, to like the square root 2 over 2 and square root 2 over 2 over here for the i's and j's. And that equals to 0, because those are the i's. Now for the j's, you have 1/2 force 1 plus square root 2 over 2 force 2 minus 100, because that's the last j, is equal to 0. And you basically do system equations. So I'm gonna, for the second equation, I'm just gonna add 100 to both sides. So that gets to equals just 100, basically. So I'm gonna have the second equation subtract from the first equation. So that would just be 1 plus square root 3 over 2 f1. Because the fourth vectors for the second one is for this side and this side is basically the same. So subtract them, these subtract each other, so it's 0. And then 100 minus 0 is 100. So basically now you could use your calculator. So you have 1 plus square root 3 divided by 2. That's multiplied by force 1, so 100 divided by that number. You got, so force 1, it's about 73.2 based on using your calculator. And you can plug 73.2 into like one of the original two equations and you get the force 2. So 73.2 times square root 3 divided by 2. I mean negative square root 3 divided by 2. And then move that to the other side. And then divide it by square root 2 over 2. And you get 89.7-ish. Right? So that's force 2. So that's basically how you find the forces. So the forces acting on the first, like the general picture was, sorry. The general picture of the box was like this. So then this would be force 1 for this line and force 2 would be on this line. So those are the forces of the wires holding the box. That it concludes like example 1. So how like forces work with like other forces acting upon it. Another example, which is one of the most common ones, like you want to move like an object across a ramp. So let's say you have something, a ramp like this, right? And this one is 30 degrees, and you have a box that weighs, let's say 100 pounds. Okay, so you want to find out how much force you want to push this at, or usually they want to ask for how much force this is pushing it at, or like if you didn't know the weight, you want how much force is this going down, basically. So what you have to do is that I'm trying to get a little bit more room. So let's say this is a 3 right here and draw a box up here. Okay. So let's say you want to find the force, right? Basically. So we know they give you that's 100 pounds. You gotta have to draw like you want to make like you want to find this vector, right? So something like parallel to this. So what you do is that you want to make a perpendicular line to of the box. So that makes a 90 degrees, right? Basically. And then you want to make so you got to think about where the forces is going. So you have a box, right? The box has a vector. A center of gravity doesn't matter how it's orientated. It could be like orientated like this, and it might look straight. Sorry, it's it might orientate like a 45 degrees, right? But the center of gravity will always pull it down. That's the general direction. It's not gonna pull it like sorry. It's not gonna pull it like this way because it doesn't make sense. You don't like put like a box to a wall, right? And then it doesn't like stick to the wall because center of gravity doesn't work that way. So it's gonna no matter what, this is gonna be pulled down, right? So you're gonna have a line that goes down, and then basically what you're gonna be doing is that you're gonna be making this kind of box. I mean triangle. So you have a line that's going down, and then you have this line that's making this height, and then you're gonna make like a line right here, right? And that makes the right triangle because you kind of want to know where the angles is going. So you have a right triangle right here, you have a right triangle right here, because this is just going straight down, right? So perpendicular to this side is just like a right triangle. So if this is 30 degrees, right? And this is 60 degrees, since this is a line, right? That means this angle plus this angle plus this angle is also 180 degrees, so this also has to be 30 degrees. You see how now the triangles are similar? Sorry, I can't write in a really small space. So this 30 degrees is 60 degrees. So we know that this vector going down this line is 100 because it weighs 100 pounds. So now we just need to find out this thing, which is since this thing is perpendicular to this line and this line is perpendicular to also this line, that means these two lines have to be parallel, right? You can also tell because these are both right angles. So this angle, this vector is the same thing as this vector. So we just need to find this side length. So we call this x. So we have we use trig. So this is sine, right? So you put sine of 30. This angle is equal to x over 100. So 100 times sine of 30 is 1/2. So 100 times 1/2 is 50. So we need a 50-pound force to move this box, basically, to like keep it still at this here, so it won't fall down. That's basically the general idea of how like the force works for like a ramp. So another way to like to understand like what the vectors do, this vector, this line would be the force to keep it still, like the box at the place, so it won't fall down. This force is from this line, basically is the weight of the object, and this line over here is basically the force right here is the force of the friction of the box to the ramp of the box of the object to ramp, physically. So how like if you're moving it, it's just perpendicular, so it's kind of be like slowing down because you have like this is kind of like it's holding it to the object. Like you just think about like real like examples. Like if you put like some kind of paper like right next to a wall, it's harder to like move it up, I guess, than if you have like the paper in the air and you try to like move it up, you know? Um And the next question, and the next topic we're gonna go on to is velocity vectors because we covered force vectors. So velocity vectors basically do the same thing. So let's try like a basic example. Let's say you throw like some kind of object, like 10 miles per hour, right, at a 30-degree angle. So you want to find, usually for velocity vectors, you want to find the horizontal speed, so the speed as it goes in the x right here, or you want to find the vertical, or you want, and you want to find this vertical speed, which is the speed that you're going up, and then there's the overall speed, which is just the hypotenuse, basically. So those are the three speeds you're going to be looking for. So based on our example, we have 30 degrees. We can make a right triangle, and then it goes at 10 miles per hour, right? Sorry about that. Miles per hour. You want to find the x and the y. So basically, use that form, which is v is equal to the magnitude. The magnitude is just 10, because that's the speed that you're going at, times cosine of 30, this is 30, because x, I, plus sine of, plus sine of 30, j. So that's the form, because using the idea of like polar form for vectors. So now you just need to find the x, which is the I is just the x. So whatever is in front of the x is basically the speed. So 10 times cosine of x is the speed, is the x speed, and the y speed would be 10 times sine of 30. So cosine of 30 is square root 3 over 2. So the speed of x is 5 square root 3. And sine of 30 is 1/2. So 10 times 1/2 is 5. So the speed in the x direction is 5 times square root 3 miles per hour. And the y direction is 5 miles per hour. So you're going up 5 miles per hour. And you're going to the horizontal direction, 5 square root 3 miles per hour. It's really just that basic. Let's try a little bit more harder one. So this is like what happens when there is like something acting on that object. So let's say you have a plane, right? A plane is moving 100 miles per hour at a north, basically. Let's just say it's going north. Sorry, north. And there's some kind of wind, right? That's usually the case. It's usually some kind of plane, and then wind is like affecting it. So the wind is moving at like, let's say 10 miles per hour at a north 60 degrees east. So a little thing about these kind of things is called bearings. So like how you read them is that you look at the first thing first, which is north. So it's gotta be north, and then you gotta go 60 degrees east, because east is this way. So north, east, south, and west. So you're gonna go 60 degrees east. So what it's telling you is that based on like the original equation, based on how the graph will usually be read, since you're going 60 degrees east from north, you're actually just going 30 degrees, right? Generally, because that's 60, 30, and that's a 90 degrees. Or let's kind of use like another example. We have like south 20 degrees west. So you're gonna be going south. You're gonna look, sorry, you gotta look at south, and then you gotta move 20 degrees the west. This is west. So you're gonna be moving right here, which is 70 degrees. So and 180 plus 70 is you're actually moving like 230 degrees. So that's basically how it works. How like bearings work. But they just use like north and south, and then like east and west for like the next bearing. Because you're not gonna be like north 60 degrees south, which sounds really weird because you're moving at the x and then moving at the y. I mean the y and then the x, which doesn't make sense at all. So based on how this works, and now you just need to calculate basically the speed. You think the speed is 100 miles per hour, but it really isn't because there's wind acting on it. So it might be making it faster. So first, let's draw a picture. So we have a plane that's going 100 miles per hour north. So it goes like this. So it's just going up. It's just this vector, north. And we have a wind that's moving 10 miles per hour, north 6 degrees east. So north 60 degrees. This is 60 degrees east. So if this is 60, that means the other side must be 30. So this is 30 degrees. 30 degrees. And this is going at 10 miles per hour. This is the wind. Okay? This is the wind, this is the plane. So now we just have to find the combined speed together. So you just have to add them together. So vector 1 is just 100j because you're just moving 100 north. And vector 2 is 10 using the polar form, cosine of 30. Sorry. Plus sine. Oops. It's a little big. Let me cosine of 30i plus sine of 30j. Sorry, it looks kind of bad. Now just write vector 2 in the common example. So cosine of 30 is square root 3 over 2. So this is 5 square root 3i. Plus sine of 30 is 1/2. So this is 5j. So the speed, them together, you just add vector 1 and vector 2. So the overall vector is equal to 5 square root 3 I plus 105j. So the speed that the plane is going in the horizontal direction is 5 square root 3 miles per hour. And the speed that's going in the vertical direction is 105 miles per hour. So it's going 105 miles per hour up, and it's going 5 square root 3 miles per hour to the right. If this is negative 5 miles per hour, it's just saying that it's going 5 square root 3 miles per hour to the left. So you just have to understand the general direction. And the overall speed would just be the magnitude. So you just have, using your calculator, you have 5 square root 3. 5 square root 3 squared plus 105 squared, and you square root that. And you'll get a overall speed of 105.4 miles per hour ish, rounded, which is a little bit faster than the original speed because the wind is helping it. So that's how it works basically. So this would be the horizontal speed, vertical speed, and overall speed. So but also if the wind was, it's because the wind was going like kind of in the positive direction, which is helping the plane. If they were going into opposite directions, let's say this wasn't the way the wind, then wind was going this way, then basically you're gonna have a positive x and a negative y. So this would be positive, so this would be like a little around this number, and then you have negative y, so it would be a little less than 100 or a little more, I don't know, based on like how big is the magnitude of the wind. Like it might be going faster, and then you just you basically do the exact same process, and then you just find out how fast it's going. So what you do is that you find the vector of the plane, then find the vector of the wind, add those vectors together, and then you find the magnitude of that vector, which gets you the overall speed. That basically covers velocity vectors. So overall, that covers the general idea for force vectors and velocity vectors. Thanks for watching, and I'll see you at the next math record.